Sanjay, you have done very well in the test.
Yes, ma'am.
I think your marks are the highest. Sai Kalyan, are you there?
More, ma'am.
Huh?
But I expected more, ma'am.
You expected more? Let us see. We'll discuss the paper. Hariharan, you have also improved. You could have just got a few more marks, but you have done better than last time. That's very good. Sai Kalyan, what happened to you? You didn't write the exam.
Yes, miss.
Why you didn't write the test?
I wrote it, miss.
You wrote it?
Miss, I was the only one. Miss, I was the only one to come to the center and write, miss.
Oh, so your paper is not corrected?
It is corrected, miss. I got 26.
Oh, so I didn't see your paper because they sent me only 4 papers and your paper is not. Ashwin, Sanjay, Vaishnavi and Hariharan. So the last paper he has, I in fact asked, I have only 4 children written. He said, yes, only 4. So I was wondering what, because the previous day you were there in the class, so I was wondering what happened. So, Sai Kalyan, you got 26 out of 40. There were some questions which I agree that we have not discussed in our classes. That is like, for example, distinguishing tests. I had not taught you. So I missed on that. Anyway, we will discuss the paper. In spite of not knowing the distinguishing test, and I have not taught, but Sanjay and Hariharan both wrote those answers.
Ma'am, I got
Ashwin has also come. Ashwin? Hi, Ashwin. Ashwin? Ashwin Shiva. Are you there? Yes. Switch on your camera. I want to tell you something. I always see you upside down in the beginning. Are you watching this class on a telephone, on a mobile phone? Ashwin, are you watching the class on the mobile phone?
Yes, ma'am.
Yes. What happened to your laptop?
Ma'am, I can't. Ma'am, the timing is not. I came late from my school, ma'am.
Okay. Okay. So, but you have done very well this time. I am happy. Compared to last time when you did not write properly, but this time there is definitely improvement. And I am happy you have done better because you didn't attend all the classes, yet you could answer very well. That is very good. Now you take a little more, care, try a little harder. I am sure you can do much better next time. All right, Ashwin? Very good. Well done. I am very happy. Then Vaishnavi. Hi, Vaishnavi. Yeah.
Hello.
So you got your marks, Vaishnavi?
Yes, ma'am.
So, in your case, I know you have you depended only on what I taught in the school, then moreover in the class, and moreover, you were absent for one class. So that is why probably you could have done better. There are some places where you have lost marks, like distinguishing tests. Those things I will discuss just now. So pay attention on that. And we should be able to. And Sai Kalyan, where did you lose marks? Tell me, I didn't see your paper.
It is corrected only, miss.
It is corrected, but you got 26 out of 40. So what happened? Why did you get, I expected more from you. What happened?
I didn't study ethers, miss.
You didn't study well for this test.
Miss, I studied only, miss, but I didn't study ethers.
Ethers you didn't study. Okay. Okay, never mind. So yeah, so if there's something you didn't understand, we should tell me. Anyway, let me.
Now I studied, miss.
Okay, good. So we will discuss the paper quickly and then we will start the new topic. So just in case, like last time, Sai Kalyan, you had got more marks than what you. So if you have lost some marks here and there, you must tell me. We can make the amendments. Okay. So we'll start discussion. All of you just pay attention wherever. Anyway, all of you have seen your marking scheme, but in case you have any doubts, we can discuss those now. Yes. Okay, so the first question, Vaishnavi, tell me the answer. Now you understood your mistake, Vaishnavi.
Yes, ma'am.
What is the mistake? Tell me. The numbering was wrong, right? So you must remember when you hear others, I think got it correct. See, the problem is the mistake that you made was you started numbering from the left. Vaishnavi, do you understand? You have to number it from the right. Why? Because OH is what? The secondary suffix. And the secondary suffix gets more weightage in numbering. So you should always number from the end which is closest to the functional group which forms the secondary suffix. So you have to start numbering from the side of OH. So this is 1, 2, 3, 4, 5, and 6. So Vaishnavi, what is the answer for this?
2-hydroxy-5-chlorohexane.
It is, how can it be hydroxy?
Sorry. 5-chlorohexane 2-ol.
Right. So it is 5-chlorohexane 2-ol. When does it become hydroxy? Tell me. It becomes hydroxy if there is any functional group which is higher than OH. So supposing there was a COOH in this, then I would have called this hydroxy. But here the main group is OH. So numbering is according to the OH, and the suffix, secondary suffix, is also all, which is according to the OH. Okay, so this was one question where you could have got the marks. All others, I think, got it correct. Now, which of them is most acidic? Many of you have written phenol is most acidic. Now, when we learned, I showed you there are two types of groups which can be present on the benzene ring. One is EWG and the other is EPG, electron pumping groups and electron withdrawing groups. Electron withdrawing groups, they always enhance the acidic nature. If there is a group on the benzene ring which is electron withdrawing, then the alcohol will become more acidic. So here if you see cyclohexanol, this doesn't have a benzene ring. Phenol is acidic definitely. Then metachlorophenol. So what is metachlorophenol? This is phenol, and on meta position there is a Cl. Now when a substituent is present, I did tell you that when a substituent is present on the meta position, its effect is less, but it is there. So Cl is electron withdrawing, so it will be more acidic than phenol. And the D is benzyl alcohol. Alcohols are definitely less acidic than phenol. So the answer is metachlorophenol. Okay. Then how many alcohols with C4H10O are chiral in nature? So this question I have discussed in the class, if you remember. Answer is only one. Hariharan, did you understand? You have got this one right. There is only one alcohol which is chiral in nature. Chiral means what? Which has a asymmetric carbon atom. Asymmetric carbon atom. What is the asymmetric carbon atom? Tell me. What
I
is
didn't
it?
get it right, ma'am.
You got it right?
No, ma'am. No, ma'am.
So you made a mistake.
Yes,
What
ma'am.
is the asymmetric carbon atom? Sai Kalyan, tell me, what is the asymmetric carbon atom?
There's 4 different atomic groups on the states of carbon.
Or all 4 groups should be different. So if this isomer of C4H10O, this isomer of C4H10O, if you see, this is C4H10O, 2-butanol. It has 1, 2, 3, and 4 different groups around it. So answer is 1. Only one of them is like that. All others will have some group which is common, so it cannot be. Now, next one. 1 mole of organic compound with the formula C3H8O completely reacts with 2 moles of HI to form 2 moles of HI to form X and Y. When Y is boiled with aqueous alkali, forms Z, and Z answers iodoform test. The compound A is, okay, now it is C3, sorry. It is C3H8O. Okay, so C3H8O means what? It is this question is question number 4. Now there is a little mistake in this question, small mistake in this question. The mistake in the question is 1 mole of an organic compound A with the formula C3H8O reacts completely with 2 moles. It is not with 2, it is 1 mole of HI. Okay. So C3H8O means it is an alcohol or an ether. Because it is reacting with HI, giving 2 products, it should be ether. So the answer, there's only 1 ether possible with C3H8O. CH3 is CH2O, CH3. This is the ether. Right? Now this ether, it reacts with HI. So when ether reacts with HI, I told you what will happen. One alkyl group will form the iodide, the other will form the alcohol. Now always when there are both primary, then the smaller one will always form the alkyl halide because the reaction mechanism will be by SN2. And SN2 means there should be backward attack. So where there is less steric hindrance, from there the reaction will take place. So I will go here and H will go here. So what will be the product? CH3, CH2OH plus CH3I. So what is the name of that compound? All other things are unnecessary because there can be only one ether. So which ether it is? It is methoxyethane. Answer is A. It is an ether. It cannot be, even if you don't know anything else, you know it cannot be ethoxyethane. Why? Because ethoxyethane has 4 carbon atoms. It has to be methoxyethane only. Then the next question, 5th one. The IUPAC name of this one. Now, Vaishnavi, this one I think you got it correct. Tell me the name.
Ma'am, 2-methyl-butane-2-ol.
5th one, 2-methyl-butane-2-ol. Correct. That is correct. Now everyone is there. Let me find out. Hari Raghav. Why didn't you write the test, Hari Raghav?
Ma'am, I wrote. Ma'am, marks have come.
Marks have come?
Yes, ma'am.
How much did you get?
16.
Oh. So what happened, Hari Raghav? Did you understand, or were your mistakes? Were you not well prepared for the test? What happened?
No, ma'am, I was having a school test, ma'am.
So you couldn't prepare. Okay. Williamson synthesis is used for the preparation of. Who will tell me? Sanjay? Williamson synthesis is used for the preparation of
Ethers, ma'am.
ethers. Very good. Then the seventh one is for Ashwin. Tell me. Monochlorination of toluene in sunlight followed by hydrolysis. This also we have done in the class. So this is
Benzyl alcohol.
benzyl alcohol. Those who did not understand how this is toluene, right? Toluene. On monochlorination, toluene will form CH2Cl, and this with aqueous NaOH, right? It will form benzyl alcohol, right? CH2OH. Now, phenol on distillation with zinc dust. What does that give? Phenol on oxidation with zinc dust.
Benzene.
Benzene. Very good. Anisole can be prepared by the action of methyl and iodide and sodium phenate or phenoxide, sodium phenoxide.
Williamson
The reaction,
reaction.
Williamson's reaction, Williamson's reaction. Okay, the next question, I will just put it there. We did up to which question number? 9. So this is 10, 11. So there were 9 MCQs. Now 10, 11, 12, and 13. Now see this question. Name the compound which can be used as antiseptic as well as disinfectant. So the answer for this, I think many of you have got it right. The answer for this is phenol. Phenol can be used as a disinfectant and also as an antiseptic. Okay, so a very, you know what is the difference between a disinfectant and an antiseptic? Can anyone tell me what is the difference between the two? Vaishnavi, can you tell me what is the difference between a disinfectant and antiseptic?
Ma'am, antiseptic is something which is consumed to increase the immunity inside our body, ma'am. And disinfectant is something like to prevent it from getting wasted by the microorganisms.
Okay. What you are saying, Vaishnavi, is not an antiseptic. It is an antibiotic. So something that you consume internally, that is antibiotic, which will get rid of the bacteria if you consume it, right? Now, Sanjay, tell me, what is the difference between disinfectant and antiseptic?
Ma'am, antiseptic is something we'll use after we get hurt or something.
And
Disinfectant we'll use in hospitals and all for protection from bacteria.
Yeah, so antiseptic can be applied on your skin, on living tissues, it can be applied. So when you get hurt or you get a fall, you apply Dettol on the surface, that is antiseptic, right? Now when you mix some something in water and apply on non-living surfaces, then it becomes a disinfectant. So many antiseptics cannot be used as disinfectants, and all disinfectants cannot be used as antiseptics. All disinfectants you can't apply on the skin, they may be harmful. Some of them, when they are in very dilute solutions, they can be used as antiseptics, and when they are concentrated, they can be used as so one such example is phenol. Is it given? 9. All right. Then, so very dilute solution is used as antiseptic. Slightly concentrated solution can be used as disinfectant. Disinfectant is one which is applied to kill the microorganisms on non-living surfaces. On floors, you use disinfectant. But if you apply it on the skin or on a living tissue, then it is an antiseptic. Okay. Give chemical test to distinguish between compounds of in each of the following pairs. Now this one, I agree that I know the first one at least, I agree. I have not given a test for this. In case you had seen the textbook, you would have answered. Now, Vaishnavi, you didn't get marks for this one. The mistake that you have made, you have written all correct reactions, but the problem is those reactions which you have written cannot be used as distinguishing tests. What is a distinguishing test? That test which one compound gives and the other does not. But that is not enough. It is also important to find that test which gives a visible observation. Either there should be some characteristic smell, or there should be a precipitate which shows a characteristic color, or the solution should have a different color. Then with that observation only you can have a distinguishing test. If both are having colorless solutions, then you cannot say which one is which. So when it is specially mentioned chemical test to distinguish, then those tests which you wrote cannot be used as distinguishing tests. So for phenol and benzyl alcohol, whenever one of them is phenol, you can use neutral ferric chloride. Okay, neutral ferric chloride. It gives a many of you have written neutral ferric chloride, but you didn't write, you got the marks, but you didn't write the complete observation. What is the observation of phenol with neutral ferric chloride?
Violet.
You get violet color. You get a violet coloration. So the solution turns violet. This test you will do in the lab also. When you do phenol in the lab, you will do this test, special test for phenol, and you have to always write, when phenol is treated with neutral ferric chloride, we get a violet coloration, but benzyl alcohol does not show this test. Okay. Now butan 2-ol and 2-methyl propan 2-ol. Here you can take Lucas reagent. This I have discussed in the class. Lucas reagent. Lucas reagent again is a reagent which will show visible observation. That means the solution becomes turbid, or it becomes what you call, the solution becomes milky sort of, because, or cloudy, because this is a tertiary alcohol. So tertiary alcohols give this test immediately at room temperature, Lucas reagent, with Lucas reagent. And 2-butanol is secondary alcohol. It happens after 5 minutes. So the one which gives immediate turbidity, you call it with Lucas reagent, you get turbidity. So the one which gives immediate turbidity, that is tertiary, and which gives turbidity after 5 minutes is a secondary alcohol. The primary alcohols don't give turbidity at room temperature. They have to be heated to get the turbidity. So that test can be used to distinguish between primary, secondary, and tertiary alcohol. Now give the structural formula and name of the product of the following reaction. Phenol is treated with excess of aqueous bromine. So many of you have written this correctly. You will get with phenol, you know what will you get? Excess of aqueous bromine, you will get 2,4,6 tribromophenol. Okay, so this is the structural formula, and the name is 2,4,6 tribromophenol.
Miss.
Tell
Miss, for 11th one, 11th second one, butan 2-ol, 2-methyl propane 2-ol can't be a Grignard reagent test.
You can, how can you do the Grignard? What will you do? Tell me. How?
When butan 2-ol, it reacts with any aldehyde other than methanol, it gives it gives the secondary alcohol, miss. But when 2-methyl propane 2-ol,
what you are telling? Sai Kalyan, what you are telling is a preparation of 2-butanol and 2-methyl 2-propanol. You have talked about how you will prepare them. Now, when you write distinguishing tests, you are given, what does it mean? In the lab, you are given 2 test tubes. One contains butanol, one contains 2-methyl 2-propanol. You have to identify. How will you do it? Not by preparing them, right? Methods of preparation are different. Your reactions are correct, but that cannot, what is it?
Miss, I will first react to the ketone, miss. Whatever it's getting, and whatever is undergoing the reaction, that is 2-methylpropane to wall, and which is not undergoing is butane to wall.
Right. But you already have 2-methyl 2-propanol. How will, why do you need to prepare it? You already have it. How will you know that the one that you have prepared is 2-methyl 2-propanol? Okay, you prepared 2-methyl 2-propanol and you prepared 2-butanol, right? By using your reagents. Now, which is 2-methyl 2-propanol in the test tubes that you already have? How will you identify them? How will you find out that the one which you prepared with acetone and Grignard reagent is similar to the one that you have got in the test tube? How will you prove that? So what you are doing is you are preparing two compounds which are given here. You are preparing them. But what my question is that you have these 2 compounds. How will you identify which is which? Okay, you are already given 2 test tubes. You are not, you don't have a method to prepare them. You already have. You only have to find a reagent which will distinguish which one is 2-butanol and which one is 2-methyl 2-propanol. That is what is the distinguishing test. Many, like supposing you have to distinguish between ethanol and phenol. How will you distinguish? Tell me. Ethanol and phenol. Anyone tell me, how will you distinguish between ethanol? This is a colorless solution, ethanol. And another colorless solution is phenol. How will you distinguish?
Color, ma'am. Phenol is brown color, ma'am.
No, phenol, I'm saying it's pure phenol. Phenol is brown color only when it is
Then
oxidized.
ferric chloride, ma'am. Neutral ferric chloride,
Ferric
ma'am.
chloride. So why do you, so you don't sit and prepare phenol and ethanol there. What you do, you use a reagent which you can add to both of them, and where there is a
Color, ma'am.
All right. So you have to identify a reagent which can bring about a visible observation. That is a distinguishing test, right? Okay. Explain the fact that in aryl alkyl ether, the alkoxy group activates the benzene ring towards electrophilic substitution. So alkoxy group, why does it activate the benzene ring towards electrophilic substitution? Due to which effect? Anyone tell me? Who will tell me? Plus M effect. Okay, CH3 group has a plus M effect, and because of that, it activates the benzene ring towards electrophilic substitution. It directs the incoming substituents to ortho and para position in the benzene ring, because due to plus M effect, the electron density is increased on ortho and para position. Okay, that is why it becomes ortho para directing. OCH3 is ortho para directing. Okay, so you can write OCH3 is what? Ortho para directing. Why? Because ortho para positions become electron rich because of plus M effect. Okay. Now the last.
12th one is tribromophenol, right, ma'am? 2,4,6 tribromophenol, ma'am.
Yeah, tribromo. 2,4,6 tribromo.
I got only 1 mark, ma'am.
I will check. If you have got 1 mark, this question carries how many marks?
2 marks, ma'am.
2 marks. So then you should get this. This is a correct answer. 2,4,6 tribromophenols. Maybe I think in your case, I will just check and then I will get the mark changed.
Okay.
Okay. Okay. Now describe the mechanism of formation of diethyl ether from ethanol in presence of concentrated sulfuric acid. Now this mechanism, formation of diethyl ether from ethanol. So I'll show you the mechanism here, how you have to write it. So ethanol is CH3CH2OH. Okay, and you have to get from concentrated sulfuric acid. So concentrated sulfuric acid, it gives what? It gives H plus HSO4 minus. So this H plus comes and joins here, H plus. It forms a bond here. So because of adding H plus, this becomes CH3, CH2, O, C, H, H, and this acquires a positive charge. This oxygen acquires a positive charge. Because it acquires a positive charge, water is eliminated. So what this changes into? It changes into CH3, CH2 plus H2O. Water is given out. Okay, now there is always more alcohol. Alcohol now acts as a nucleophile. So OH, how it is removed? By protonation. So first step is protonation of alcohol. Water is eliminated, carbocation is formed. Next is the C2H5OH, right? That comes in as a nucleophile. So this attaches to, this whole thing goes and attaches to this carbon. So what you get? CH3, CH2, and here O, here H, and C2H5. Now this oxygen has now a positive charge. So this molecule is not stable. So this H now leaves. Why does it leave? It is taken away by HSO4 minus. HSO4 minus helps in removing this. And so it becomes what? CH3, CH2O, CH2, CH3, right? So sometimes such conversion, mechanisms, there are altogether in CBSE, you need to learn 4 mechanisms. So this is one of them. Now, if you have difficulty in understanding it or remembering it now, leave it for the time being, no problem. Nearing the exam, we will revise it, because now if you don't understand it, then you will anyway forget. So if you understand, it is good, but when we do revision nearing the examination, then we can do it again. Now here, this part I was happy, many of you have written good answers. Oxidation of primary alcohol to carboxylic acid. What can you use? You
Alkaline
can use,
KMnO4.
you can use alkaline KMnO4. If somebody has written K2Cr2O7 and H plus and has not got marks, please tell me now. So you can use or alkaline KMnO4. So if somebody has not got marks for writing this, one of these, then you let me know. Then oxidation of primary alcohol to aldehyde, only to aldehyde, not to acid, but to aldehyde. What can you do?
PCC, ma'am.
PCC. You can also write copper at 573 Kelvin. That is also correct. Bromination of phenol to 2,4,6 tribromophenol by adding what? Bromine water.
Bromine water.
Yeah. Benzyl alcohol to benzoic acid. Again, alkaline KMnO4. Dehydration of propan to all to propene. Okay. So what is the dehydrating agent?
Concentrated H2SO4, ma'am.
Yeah. At 170 degrees. Butanone to butan to all. This is reduction. So what will you use? NaBH.
Use lithium aluminum hydride, ma'am.
Or lithium aluminium hydride. Both are correct. Nitrophenol has a lower boiling point and is more volatile than para-nitrophenol. Okay, because orthonitrophenol has intramolecular hydrogen bonding and para-nitrophenol has intermolecular hydrogen. So this one has inter and the other one has intra. Inter and intra, that is a difference. All right. So that was now the last question.
Miss,
Yes, tell me.
Miss, for the last question, I got only 2 marks, Miss.
Same here as well.
I will just check on that. Just 1 minute. I'll copy the other questions and you. So you are saying that for the previous last question, nitrophenol and this question carries 3 marks. So you got only 1. Sai Kalyan, can you read out the question answer to me? What did you write?
Miss, I wrote orthonitrophenol as less boiling point compared to paranitrophenol because orthonitrophenol experience intramolecular hydrogen bonding, whereas paranitrophenol experience intermolecular hydrogen bonding, and whichever has less boiling point and steam will be more steam volatile. When steam is passed to orthonitrophenol, it goes off with the steam, that is no reaction.
Yeah. Good. You should get 2 more marks then. You have got only 1. Who else got only 1 mark here?
I got 2 marks.
You also wrote the complete answer or
Yes, ma'am, due to intramolecular hydrogen bonding.
Maybe. I think maybe they might have reduced your marks because did you draw the structure showing intermolecular and intramolecular?
No, ma'am.
So if you, so you should always draw the structure to prove that. So 1 mark, if it is reduced, it is okay. Sai Kalyan, you can add 1 more mark to your total. Okay. So now let us look at the next question. The owner of the paint industry who was using ethanol as a solvent noted his stock of ethanol was misused by his employees. To prevent this, he added a small amount of blue colored compound A and another nitrogen containing heterocyclic compound B, which gives a foul smell. Do you think he took the right decision? Yes.
Yeah.
Simple answer, yes. Now, what is the blue colored substance? I have told you the name of the blue colored substance, although I did not tell you the name of the second one. So the blue colored substance is copper sulfate. Okay, so they often add copper sulfate to make the alcohol unfit for drinking. So that is why. And B is pyridine. This I have not told you. So all those who have written copper sulfate, I would give 1 more mark to them because this part I have not discussed. So you cannot be,
I wrote copper sulfate.
Copper sulfate. So you can add 1 mark to your total.
Even
What
I wrote
about you? Sanjay, did you write both of them?
1 word from also.
Vaishnavi, what did you write the answer for this?
Which one, ma'am?
The, write the names of compounds A and B. Did you write any one answer for this?
Ma'am, I wrote copper sulfate.
You wrote copper sulfate, very good. So if you have written copper sulfate, then you will get full mark for, I mean, like if you, how many marks for this question, which was 5 marks? Actually, this 18 carried 2 marks. So you can give yourself 2 marks. So if you have got 1 mark for this, you can make 1 more, add 1 more.
Ma'am, actually, I have
Okay.
not written this question, ma'am. I went out of time.
You did not write anything for this question?
No, ma'am, I have not attended 17, 18, and 19.
Okay. Consumption of methylated ethanol, I will have a look at your answers, and for all those who have attempted partly, I will give you marks. Then consumption of methylated ethanol by a person can cause blindness and even death. How is methanol poisoning treated? So on the last day, those who didn't attend the class may not be able to answer this. So methanol poisoning is treated by giving more alcohol, excess of alcohol initially. You give more alcohol, so the alcohol is absorbed by the brain and methanol does not affect. So that is to uh, treat you for methanol poisoning. I don't know what they have written in the marking scheme. Let me see. Methanol poisoning. Yeah. 10% ethanol is administered intravenously is safe and effective antidote for severe methanol poisoning. So you have to add, treat it by giving more ethanol. So this part I have discussed in one of the classes. On that day, not many people were present. So this you should have answered. And there is a paragraph about it in the textbook. Please read that up. It comes in the board exam also. A liquid was mixed with ethanol and a drop of concentrated H2SO4 was added to it. The compound had a fruity smell. What was the liquid? The liquid was ester, right? And what was the liquid to which ethanol was? It was
Acetic
added.
acid, ma'am.
Yeah, acetic acid. Any acid you could have taken, but acetic acid is also correct, right? So A has a fruity smell. That means it is ester. Now write the structures of the compounds A, B, C, D here. So what is A? Zinc dust does
Benzene.
what? A, you get benzene. So A is benzene. What is B? Nitrobenzene, right? When you do bromination of nitrobenzene, that day I showed you this reaction. Bromine will come where? On the meta position. Br will come on meta position. Then you do reduction of this part. So this question actually, again, I feel many of you may not have attempted, have not got it
I put
right.
tribromobenzene, ma'am.
Not tribromo. It cannot be because NO2 deactivates the benzene ring. You cannot, you will get only one. This question, the first part, I have done in the class, so I know. But the second part, I have not done this. Then with HNO2, you will get N2Cl, N2 plus Cl minus, and with water, it will give you Br here and OH here. Meta nitrobromophene. Okay. So all those who have attempted, I will have a look at your answer papers. If you have answered A and B and C correctly, I will give you marks for the others, because this part you are not expected to know because I have not taught you. Yes, tell me, Saikalyan.
B2C is there, no miss. The appropriate reagent was not given, no miss. CS2
Which
is
one?
not from B
Where?
to C. B to C, miss. They are given only
It
BR2.
is, see, it is, yeah, complete reactants are not given. They should have written FeBr3, without which the reaction will not happen. I agree with you. And moreover, but when Br2 is there, that is a mistake, I agree. NO2 is only meta-directing, and all meta-directing groups, they are deactivating. So you cannot get bromine on all the positions. You will get only on one position. Okay, so you pointed out correctly, the reactants are not complete. So even for C, right, even for C, if you have not, let me go through this, how you all have answered, and I will add some marks there. Then the last one is account for the following. This is again repetitive question, right? So Here also you may have lost marks because of not writing the structures. Otherwise, you should get. Then tertiary butyl chloride on heating. Is this the last question? Let me just check. 22.
B and C,
No,
ma'am.
no, there is B and C also is there. So here, this is tertiary butyl chloride with sodium methoxide gives 2-methyl propene instead of tertiary butyl methyl ether, right? This also I have explained very nicely to you. I hope you have written, all of you have written correct answer. Tertiary butyl chloride, if we take tertiary butyl chloride, the reaction will happen by SN1 mechanism. And when the reaction, when the substrate is tertiary butyl, then the probability of substitution is elimination is more. Okay, so that is why you will. So the reaction should happen. The substitution product you get more easily if your substrate is a primary alkyl halide. That is right. Then the next one is you had to write the products of the Reaumur-Tiemann reaction that all of you have, I think most of you have written. Chemical test to distinguish between ethanol and phenol. It is again adding neutral ferric chloride to both the compounds, and phenol will give violet coloration. So that is the whole paper. I hope all of you, I'll again go through your paper. I got the papers only today. I'll go through the corrections, and if there is any place where you need to get more marks, I will add. All right. So that is about the paper. Now we will.
B and C, ma'am.
B and C is Reaumur-Tiemann reaction.
Yes, ma'am.
You get salicylaldehyde, and C is add neutral ferric chloride to both. You have to distinguish between ethanol and phenol. I told you in the beginning, if it is ethanol and phenol, you all said it is neutral ferric chloride. Okay, you get a violet coloration. Okay, so I'll leave this now. All of you, you have done better than last time, definitely, but you can still improve. Some mistakes are on my side because I did not teach the distinguishing test, but otherwise you should all try to do better. Okay. Now we will start a new topic today. And the new topic that we are going to start today is electrochemistry. How many of you have already started electrochemistry in school? Anyone?
Our school started, miss.
In class you started? Very good. And others, Hariharan, what are you doing in school?
Ma'am, in biomolecules, ma'am, we are now.
Oh, biomolecules. They jump to biomolecules. Why?
Yes, ma'am. This exam is coming, ma'am. Portions it is.
But biomolecules is one of the last ones. Anyway. And Sanjay, what are you doing in school?
Ma'am, they're doing amines.
Amines.
Yes, ma'am.
So aldehydes, ketones over.
No, ma'am, they skipped.
So they skipped aldehydes, ketones, and straight went to amines. Oh, what about you,
Yes, ma'am.
Vaishnavi? Vaishnavi, what about you?
Ma'am, they are in alcohols and phenols.
You are in alcohols and phenols. Hari Raghav, where did he disappear? So you have already done electrochemistry or you are going slowly? Vaishnavi?
No, ma'am, they are completed haloalkanes, and the second chapter is alcohols.
Okay, so you have not done solutions, but.
Yes, ma'am, they are not done.
Okay, so we are better here. So now let us do. So, you know, Vaishnavi, once you learn here and then you hear it in the school, I think you will be able to do better, right? Now we will learn this topic called electrochemistry. Okay. Some little electrochemistry you have done in class 11, I think. That is in redox reactions. haven't you? You have done the redox reaction in class 11, balancing the equation using, oxidation reduction method or by ionic equations, half reaction method. You have learned all those things in class 11. So what is the meaning of electrochemistry? See, when I say electrochemistry, I mean, it means there is some relation between what? Electricity and chemistry. Okay, there has to be some relation between electricity and chemistry. Right? So what is the relation between electricity and chemistry? Okay, so there are two types of reactions you can see. One is those reactions which produce electricity. So first one are those reactions, chemical reactions, which produce electricity. Right? Can you see do you know of any chemical reaction which produces electricity, which you use in everyday life? Where do you see a chemical reaction happening which produces electricity, which you use in everyday life? Tell me. Anybody?
Batteries, ma'am.
Batteries. So the batteries, okay, so batteries are group of cells that you use. You can use a cell in a batteries or cells. Group of cells are known as batteries. The battery is used in your car to start. It produces current. Then you use battery in your torch where it produces it. You use battery in your laptop. So everywhere where you use a battery, there is a chemical reaction happening in the cell so that the electricity is produced, which helps in running your whatever system you are using. You can use batteries in watches. You can use batteries in so many places. So many toys they make use of. They run around, they produce light, electricity because of this battery. So first set of reactions are those which produce electricity, and such reactions, in such systems which produce electricity, we learn them under galvanic cells. The second type are those reactions which require electricity, which do not happen without electricity. So those reactions which do not happen without electricity, they are also, we learn under electrochemistry. They come under electrolysis, where using electricity, we break a compound, we bring about a reaction, or a reaction happens with the help of electricity. So two types of reactions which are spontaneous, and when they have those reactions happen, electricity is produced. And the other are those which will not happen otherwise, but with the help of electricity, the reaction will take place. So that you learn under electrolysis. There you use a electrolytic cell, and in batteries, the cells that we use, they are galvanic cells. Okay, so that is both. These are the two things that we will learn in electrochemistry. The third thing before, yes, tell me.
What is hydrolysis, ma'am?
Hydrolysis is breaking something using water. Hydro, this is relating to water. Lysis means to break. So if you break something using water, then you call it hydrolysis. Now, when you do hydrolysis can be done with water. Hydrolysis can be done with an alkali like sodium hydroxide. So then it is called alkaline hydrolysis. You can do hydrolysis with the help of an acid. Then we call it acidic hydrolysis. So hydrolysis of alkyl halides. If I do alkaline hydrolysis of alkyl halide, like for example, if I take methyl chloride and I do alkaline hydrolysis, then what does it mean? Methyl chloride breaks. Lysis means to break. So methyl chloride breaks and methyl chloride changes into methyl alcohol because of presence of OH in alkaline solution of sodium hydroxide. So hydrolysis means breaking with the help of water. Anything that you break with the help of water is hydrolysis. Okay, so the third part of this thing you should know is what is electricity? We talked about the chemical reactions. What is electricity? This is the physics of it. Tell me, all of you. What is electricity? Any one of you? So what is electricity? Anybody who can answer what is electricity? Sai Kalyan, what do you think is electricity?
Miss, flow of electrons through a conductor.
What is it?
Flow of electrons through a conductor.
Flow of electrons. Yes, it is flow of electrons. So Hariharan, Sanjay, Sai Kalyan, Ashwin also has gone. Oh God. So this electricity is what? Flow of electrons. So keep all these things in mind and then you answer the questions which we come across. Now, next. So I have now two pictures for you. Right? Now in these two pictures, what do you see? Here I have a beaker in which there is, you can see copper sulfate solution, right? And there is a zinc rod which is immersed in it. This is a zinc plate which I have immersed in copper sulfate solution. On this side, what do I have? On this side, I have zinc sulfate solution and I have put a copper, I have dipped a copper rod in it. All right. So the two things if I were teaching you offline, I would have shown you this experiment. It's a very easy experiment. So you take copper sulfate, put zinc rod in it, take zinc sulfate, you put copper in it. Here this is blue colored solution, make the observations. Here it is a colorless solution. Now what will happen after 5 minutes? I leave them for 5 minutes. What will happen? Who will tell
A
me?
layer of copper on zinc sulfate.
Yeah, so this is what will happen. There will be a layer of copper deposited on zinc. What will happen this side? No
Layer of
reaction.
zinc, ma'am? A layer
What?
of zinc?
No. Can you see after 5 minutes, it is same. There is no reaction. So what can I do here? Here, what was the reaction? I had copper sulfate and reaction with zinc. So the solution became, what was the observation? Solution became colorless. So all the copper has changed into copper sulfate. What is the color? Blue. Why is the color blue? Because of copper ions. All the ions have got precipitated. So what did I get? Zinc, sulfate, and copper. See, here no reaction. Right? So what did I see? That if I take zinc sulfate and copper, there is no reaction, no change. Okay, did you understand this? Now, let us try to analyze what is the reaction which is happening. Okay, yes?
I have a doubt, Miss. By seeing the reaction, how can we find that which element is which element is cathode and which element is anode?
We will find out. We will find out. I am going to tell you that only. Okay. So now I'll write that reaction here. So what was the reaction? Copper sulfate plus zinc, right? It gave you zinc sulfate plus copper. Okay. Now what I want to do is I want to change it into an ionic equation, ionic equation. So copper sulfate is an aqueous solution, zinc is solid, zinc sulfate is an aqueous solution, and copper is solid. I should have told you in the beginning. When I showed you the picture, it was understood that it was an aqueous solution. Copper sulfate not solid, but in a solution. So if I change it into an ionic, I can write ions for this. So what will it be? Cu2 plus SO4 2 minus plus Zn. Okay, what is solid will not, nothing will happen to it. This will change into Zn2 plus SO4 2 minus plus Cu. Right? Now what I can do? I can cancel out the ions which are not participating in the reaction. So they which are same on both sides. These ions are called spectator ions. So you cancel the spectator ions. So what is the equation? Ionic equation is Cu2 plus Zn giving Zn2 plus Cu. Right? Now you look at Zn first. Zn has changed into Zn2 plus. How do you think Zn changed into Zn2 plus? Zn to Zn2 plus. How did it change? How did it become? Why did it become Zn2 plus? Obviously, it has lost 2 electrons, right? Because it has lost 2 electrons, right? So from here to here, what is happening? There is a loss of electrons. Now look at copper, Cu2 plus, how does it change into Cu? It has gained 2 electrons, right? So this is gain of electrons, right? So zinc, basically what has happened? Zinc has given electrons and copper has gained electrons. In that solution, what was happening? Inside this solution, what was happening? Continuously, zinc was giving electrons and copper ions were gaining electrons. They were doing that. Here in this case, it did not happen. That I will explain later why not. But in this case, definitely this is what happened, that zinc, so there was transference of electrons. Okay, so what basically I am trying to say is this, there was transference of electrons from zinc to copper. Zinc was giving and copper was taking. But was there electricity produced? No. Why electricity is not produced? Because within the solution, electrons are coming out of zinc and copper is using it, and it is getting precipitated there as copper. This big thing of the copper precipitate is happening because it is absorbing electrons. All electrons are given out by zinc, right? So electricity is not getting produced. But if I separate the two reactions happening, then probably I can produce electricity. So before that, let me tell you, loss of electrons is what? Who will tell me what is loss of electrons? What is loss of electrons known as? Anyone? Loss of electrons is known as oxidation, right?
Gain of electrons.
And what is it? Sorry, oil rig. You can learn it like this. I can write it in yellow here. Oil. Oh, sorry. You can learn it like this. Oil and rig. Right? So what is oil? Oxidation is loss. And what is rig? Reduction is gain. So what is happening in the first case? Oxidation. And in the second case, copper is gaining electrons. So what is happening here? This is reduction. Right? So this whole reaction, which I have written here, what type of reaction it is? Redox reaction. So in redox reactions, there is a gain as well as loss of electrons. So their inner reaction where there can be gain or loss of electrons, that reaction can be used for producing electricity if there is a spontaneous gain and loss of electrons. So the reaction happens in the first one. Why? Because zinc has a tendency to lose electrons and copper has a tendency to gain electrons. So this combination of zinc and copper can be used for making electricity. So let us try to make electricity. So what I will do now is I will take two separate beakers. So one beaker here and one beaker here, two separate beakers, right? And in one beaker here, I will take, I'll put it with the light green color. Let me make it slightly green, this one. Okay, so I will put slightly green. Zinc is actually colorless, so let me not confuse you. Let me make it white only. So this is zinc sulfate. In this beaker, I take zinc sulfate. And in the other beaker, let me put copper sulfate. So here, what do I have? Copper sulfate. So zinc sulfate and copper sulfate. Now in the zinc sulfate, I put a zinc rod. I put a zinc rod here. Okay, this is a zinc rod. So zinc rod. And in copper sulfate, I will put a copper rod. So copper sulfate, let me put a reddish brown, not really the color, but anyway, this is copper. This is copper rod. Okay. Now, what is the tendency of zinc? The tendency of zinc is to produce electrons. So it keeps losing electrons. So what is the reaction which is happening on the left side? The reaction that will happen here will be zinc will change into Zn2 plus 2E minus. So zinc rod will slowly start moving. Zinc ions will start forming Zn2 plus here, Zn2 plus. And what will happen? The electrons will start collecting here. Electrons. Okay. What will happen at the copper? In this state, in this side, what will happen is that this copper sulfate has copper ions. So Cu2 plus 2E minus, it will take electrons from copper rod and it will become Cu. Okay. So the copper 2 plus ions, they will keep changing into copper and they will start getting deposited on this. And here zinc will go into solution. If I don't do anything, after some time, you will see the zinc rod will reduce in size and copper will increase in size because of tendency of copper to gain and tendency of zinc to lose electrons. But if I connect the two with a wire, right? Now, what is happening in the copper rod? There is deficiency of electrons. Why? Because the electrons, this is gain the positive charge. Why? Because the copper is providing electrons to the copper ions. So there is a deficiency of electrons. And here there is excess of electrons. So what will happen? The electrons will start flowing from zinc to copper. So I separated zinc and copper. And since I separated them, what happens? Now electrons which are produced by zinc are going to this rod quickly because this is electron deficient and this is electron. And what is flow of electrons? Electricity. So if I put a bulb here, right? If I put a bulb, the bulb will light up. Why? Because the electrons are flowing through that circuit. Okay. So this is how you produce electricity. Now, Sai Kalyan, you had a question. How will we know which is anode and which is cathode? So by convention, we say that anode is the electrode where oxidation takes place. You see, just now I told you first, and one word to remember what is oxidation and what is reduction. So oil rig. What is oil rig? Oxidation is loss and reduction is gain of electrons. Now, the same way you can learn what is oxidation. Where does the oxidation take place? Oxidation is anox. That is, anode is where oxidation takes place. And red cat. Red cat means cathode is the place where reduction takes place. So always, wherever the electrode where oxidation takes place is anode, and the electrode where reduction takes place is cathode. So by that, here is where my oxidation is happening, loss of electrons. So this electrode here on the left side, this is the anode. And this electrode where the oxidation reduction is happening, that is known as this one is the cathode. This one will become the cathode, because that is a place where reduction takes place. So what is cathode? The electrode where reduction takes place. That means the electrode where the ions are gaining, where gain of electrons is happening. And where loss of electrons is happening, that is the anode. Now here, since electrons are being generated, this electrode will be negatively, it will be the negative terminal. This will be negative electrode. This is negative. And where the electrons are coming to, because it is why they are moving towards the cathode. This cathode, they are moving because this is deficient, electron deficient. So this electrode will be the positive electrode. So in a galvanic cell, it's important to know here, in a galvanic cell, the electrode where oxidation, always, any type of cell where oxidation takes place is anode, and where reduction takes place is cathode. And in the galvanic cell, the electrode where oxidation takes place at the anode is rich in electrons. So that is why it is negatively charged, and the other one is positively charged. Electrons flow. How do the electrons flow? Electrons flow from anode to cathode. They always will flow from where? Anode, where they are generated, to cathode, which is electron deficient. Now, by convention of physics, I don't know why they do like that, but that is how it is. The current flows always opposite to the direction of flow of electrons. So electrons always flow from anode to cathode, but the current flows from cathode to anode. So if I put a voltmeter, you will see the direction pointing towards anode, because the electrons are flowing towards cathode. Question in chemistry, we always ask, what is the direction of flow of electrons? That's always anode to cathode. Now this reaction will continue and produce electricity. After some time, what will happen? There will be what will be the observation? Zinc rod, as I told you, will start with losing weight, and copper rod, what will start happening? It will start gaining weight. Zinc will start losing and copper will start gaining. Now here what will happen? There will be excess of Zn2 plus ions, right? Excess of Zn2 plus ions. There were already sulfate ions, some sulfate ions, SO4 2 minus, SO4 2 minus, and zinc. But the number of zinc ions will be more than the sulfate ions. Why? Because the zinc is going into solution. Zn atoms, zinc atoms are changing into zinc ions. What will happen at the cathode? At cathode, what will happen? There will be excess of sulfate ions. Why there will be excess of sulfate ions? Because the copper ions in solution are getting deposited on the copper rod. So there will be imbalance. Here there will be excess of negative charge, and here there will be excess of positive charge. Now the positively charged ion, the rod has become already, this rod has become negative. So these zinc ions will go and stick around here, right? And they will prevent further reaction. Similarly, sulfate ions, they will go and stick around the copper rod, which is positively charged. They will be attracted, opposite charges they attract, and they will prevent further reaction. So to avoid that from happening, what we do is we connect these two by a glass rod, inverted glass rod, right? And this inverted glass rod is filled with a gel along with some electrolyte. Now this glass rod is called salt bridge. This salt bridge is essential to help the reaction to continue for a long time. So what does the salt bridge contains? It contains a gel and an electrolyte, a simple electrolyte like ammonium chloride. Now the ammonium chloride dissolves in this gel and it is filled here. Gel, it's not liquid, it remains inside, but the electrons can flow through the gel. So what happens? Here there is excess of positive charge. So what will happen? The chloride ions will start collecting here from the gel. The Cl minus ions will start collecting here and they will attract the positive charge towards it. And on this side, what will happen? Ammonium ions will start collecting here and they will attract the sulfate ions towards it. And so the reaction can continue. So that is the salt bridge. So now for writing, so this is a cell. I will show you one more diagram. So this is how it is. So this is, I drew it in steps so that you understand. This is the type of a picture of the galvanic cell. So what I have drawn here is a galvanic cell. You can see here zinc is in zinc sulfate solution. This is on the left, you have the anode. This is oxidation happening. On the right, you write the cathode where there is reduction happening. Normally, we also use one more word, lone, which helps in identifying. So what does lone represent? L is for left, O is for oxidation, right? N is for anode, A is for anode, and N is for negative. So this helps you in telling everything about the cell. Why is this negative? I already explained. This is to memorize. So there are three words which help you to tell everything about a galvanic cell. One is lone. The other is anox and red cat. And the third is oil rig. With the help of this, we should do everything. Now, now in this case, this is a galvanic cell. So I have built a galvanic cell. Now I must learn how to write the cell reaction. Okay, so I should write the cell reaction. So how do I write the cell reaction? So this is, I'll write here, cell reaction. So in the cell reaction, this first and word will help. Left, yeah, left should be anode. And what should be happening at anode? Oxidation. So here in the left side, what do you have? Zinc. And zinc is getting oxidized. So you write Zn changing into Zn2 plus. Okay, so when zinc changes to zinc 2 plus, it shows oxidation. Then you write a double line. What does a double line show? Double line shows the salt bridge, this salt bridge. And on the right side, what should you show? Reduction. So what is the reduction happening here? Cu2 plus changing into Cu. Now under these two, you have to show their state. So Zn is solid. Zn2 plus is aqueous. Cu2 plus is aqueous. And this is solid. Other than that, what you need to write? Other than that, you have to write the concentration of the ions. So Here on this side, it is 1 molar. The solution is 1 molar. This side also, it is 1 molar. If the concentration is 1 molar, then your cell is a standard cell. For a standard cell, what is required? That the concentration of ions on the anode and also the cathode should be 1 molar. And so that is a standard cell. The concentration should be 1 m and the temperature should be 298 Kelvin or 25 degrees. So this is a standard cell. Okay, so so we did so much so far. I hope you have understood what we are doing. Now the next thing is to write the cell reaction. This is cell, this is not the cell reaction, sorry, this is cell notation. This is how to write the cell notation. So you will be asked to write the cell notation. You show what is the cathode, what is the anode. Now we will learn how to write the cell reaction. What is a cell reaction? The reaction happening at anode and cathode and added together. So first write always anode. So what is the reaction at anode? Zn giving Zn2 plus 2E minus. What is the reaction happening at cathode? Cu2 plus 2E minus giving Cu. None of you are talking, so I don't know what is happening. Only one person is there with Vaishnavi, Sai Kalyan, are you understanding? You have not switched on your cameras.
Yes, miss.
Children, I was told that if children don't switch on the cameras, you can tell them, you can remove them from the class. I don't like to do that, but if I see you, the advantage is I can make out whether you are understanding, whether you are there. It helps me also that I am communicating with you. Communication, when does it happen? Best is when we are one-to-one, when we are together, but we are not, that situation is not there. So at least help me by switching on your camera unless you have a serious problem. Okay, I can only request, I don't like to, send you out of the class for not doing this, but if you can, please. Okay. So now when I write the cell reaction, this is anode and this is cathode, what will happen? I will cancel. So what will I get? Zn plus Cu2 plus will give Zn2 plus Cu. This is called what? Cell reaction, what I wrote here. In a cell reaction, remember the number of electrons gained will be equal to the number of electrons lost. So whatever, if I lose 2 electrons, then they should be equal. If they are not, then we'll have to balance the equation. Okay, so that is cell reaction. Now we are doing all this. Why? We are doing all this because we are making a galvanic cell. So what is you have to find the EMF of the cell. EMF of the cell. That means how much current. Yes, anybody?
Go for the first slide.
This one?
Okay.
Next one. This
No,
one.
ma'am, that one.
First one.
Okay. Thank you.
Right? Shall I go ahead?
Yes, ma'am.
So we have to find the EMF of the cell. EMF is how much voltage will this current cell produce. So for that, my cell is a standard cell. So if it is a standard cell, we say EMF of the cell is represented as E0 cell. You write it like this, E0 cell. E0 means standard cell. What is a standard cell? Where the concentration of ions both sides is 1 molar and the temperature is 25 degrees Celsius. So E cell is equal to E0 cathode minus E0 anode. Okay, the values of E0 cathode and E0 anode will be given to you. So what is E0 of an electrode, E0 cathode or anode? What does it mean? It means the reduction potential of the cathode, right? And the reduction potential of the anode. So you will be given these values. Using the values, you can find the E0 cell. So for my reaction that I showed you, what is the anode? Zinc. And what is the cathode? Copper. So the values that you will be given to you will be like that. Reduction potential means copper is getting reduced. So Cu2 plus 2Cu, that is a reduction potential, is equal to plus 0.34 volts. This I'll explain in the next class, but this value is given. And similarly, zinc reduction potential Zn2 plus 2Zn, that is given as minus 0.76 volts. So when I find the E0 cell, how will I do it? It will be E0 cathode. This is E0 cathode. So that is plus 0.34 minus 0.76. So that will become plus. So 0.34 plus 0.76. So that will be equal to 1.1 volt. Okay. So you can find the EMF of the cell. Okay. Now, what is this reduction potential? That is what we will talk about in the next class. How do we find out the reduction potential? What is the reduction potential? First of all, how do we determine the reduction potential of an electrode? And all these values are in the exam given to you. They are all standard reduction potentials of each electrode of all the metals are given to you. You must have learned in class 10 the electrochemical series. The elements are arranged in the order of their reactivity. So similarly here, it is quite similar to the electrochemical series. Here, the elements are all arranged in the order of increasing reduction potential. So here you see copper has a higher reduction potential than zinc. So the one which has a higher reduction potential is likely to get reduced, and the one which has lower reduction potential obviously will then get oxidized because a redox should take place. So first decide which will get reduced. So which one will? The one which has higher reduction potential. Which will get oxidized? The one which has lower reduction potential. Okay, so we will do more of it. I hope you are understanding. This is a very interesting and a very useful lesson. I hope all of you are able to understand. Vaishnavi and Sai Kalyan, are you there?
Yes, ma'am.
Yes. Sai Kalyan, you are there? Okay. So are you able to understand, all of you?
Yes, ma'am.
Yes, ma'am.
Very good. Very good. Okay. So see you tomorrow.
Thank you, ma'am.
Thank you,
Bye.
ma'am.
Thank you, ma'am.